This is a podcast by the Straits Times.
Hi, you're listening to Green Pulse, and I'm your host for this episode, David Fogarty. This episode is all about carbon dioxide, or CO2, the main greenhouse gas in the atmosphere. We can't see it, and we can't smell it, but we can definitely feel its growing impacts as the planet heats up, with devastating consequences. And every year, the amount of CO2 keeps accumulating in the air. Human activity is producing about 40 billion tonnes of CO2 a year, and that's mainly from burning fossil fuels and from deforestation. So to fight climate change, we need not only to slash CO2 emissions, we also need to suck out billions of tonnes of the gas out of the atmosphere. And that means dramatically scaling up carbon dioxide removal technologies. We'll never reach the Paris Agreement's climate targets by 2050 unless we remove at least 4 times more CO2 from the atmosphere every year than we do at present. That's the conclusion of a major study on carbon dioxide removal released in June 2024. So what exactly is carbon dioxide removal, or CDR, and what is needed to really get investment pumping? With us today is one of the lead authors of that report, Gregory Nemeth, a professor at the University of Wisconsin-Madison's La Follette School of Public Affairs in the United States. Greg studies the process of technological change and the ways in which public policy can affect it. Welcome to the show, Greg.
Thank you. It's good to be here.
So, Greg, let's start off with a look at what carbon dioxide removal, or CDR, is, and its growing importance in tackling climate change.
Yeah, so carbon dioxide removal is human-caused removal of CO2 that's already in the atmosphere and storing it durably. So there's really 3 components that what make carbon dioxide removal: that it's intentional, that we're actually taking CO2 out of the atmosphere, and then third, that we're storing it somewhere where it will no longer contribute to global warming. So that's the definition we use. And then what's its growing importance? I mean, it really has to do with what you just described in the introduction. First of all, we've got this Paris Agreement goal of aiming for keeping warming below 2 degrees and making efforts to keep it even below 1.5 degrees. We're already at 1.2. And so that's the real driver here, is there's really not much more space in the atmosphere for putting additional CO2 into it. And yet we continue to put emissions into the atmosphere. And so because of that, we've started to say that we need to find ways to remove some of the CO2 that's already in the atmosphere. It does not mean that it's a substitute for reducing emissions. In fact, that's the bigger effort, is to reduce emissions. But carbon dioxide removal will be one of the tools that we'll need if we are to meet the goals that we agreed on in Paris of keeping warming below 2 degrees and making efforts to keep it below 1.5 degrees.
Now, just as a follow-up, I mean, obviously the key is removing the CO2 from the atmosphere at a large scale and locking it away for centuries, given CO2 lasts for centuries in the atmosphere. And it's also a little bit different from CCS, or carbon capture and storage, which is mainly focused on capturing the emissions from fossil fuels. So maybe just explain that difference to us.
Yeah, that's an important distinction to make. So CCS, or carbon capture and sequestration, is avoiding putting CO2 into the atmosphere. So we might burn coal to make electricity or burn coal to make steel. There are processes where we can capture the CO2 that comes from that combustion, pressurize it, and pump it underground. And that's a way of avoiding putting CO2 into the atmosphere. And that could be helpful in some sectors. But here we're talking about removing carbon dioxide that's already in the atmosphere, which is, in a sense, a bigger challenge and something that CCS doesn't allow us to do. So that's part of the distinction. The other part that you reference is that it is valuable to store CO2 for a long time. And when we say a long time, we mean centuries to millennia. And so we do have some methods where we can store CO2 and it actually becomes mineralized in a year and becomes essentially a rock underneath. And that's permanent storage. The opposite of that would be to say that we are storing carbon in soils by some careful management of soils, like low-till agriculture, for example. But then if we change our mind the next year and start plowing those fields, we'll lose a lot of the carbon back into the atmosphere. And so making sure that the storage is long-term is really key to making the effort at CDR successful.
Now, you were a lead author of a major assessment of CDR published recently, which I mentioned in the introduction, and that involved dozens of scientists around the world. Can you tell us a bit more about the assessment and some of the key findings? I guess some of the key findings you've already just mentioned, but perhaps just give us a few more of the top-line messages.
Yeah, right. I mean, part of the motivation for doing this big study is that we see carbon removal getting a lot of attention, but we haven't really had the chance to put all the data together for the whole world and see what the whole picture looks like. And a bunch of us had worked for the UN climate reports, the Intergovernmental Panel on Climate Change, and felt that the treatment of CDR there was insufficient compared to what attention was getting put toward it. So that was the motivation for the report. And as you say, it was dozens of scientists around the world to pull together information. What did we learn from that? What insights? First of all, I would talk about how much carbon dioxide removal is already happening. And the number we come up with is about 2 billion tons of removal is happening at present. And put that into perspective, about 55 billion tons is going into the air of CO2 and other greenhouse gases every year. And so we're taking 2 of those out every year. And so it's 2 billion tons is what the removal is. And then if we look at the novel forms of removal, which a lot of the attention and investment is really going into, that's much smaller. That's about 0.1% of that 2 billion tons. So it's a tiny amount of these novel attempts that are growing. At the same time, we also looked at how much removal we would need to do to meet the Paris Agreement goals. And there we get something like 7 to 9 billion tons of CO2 per year. So that leads us to this need for much more CO2 removal. We're at 2 billion tons now. We need to get to about 8 by 2050. And the challenge is, how do we actually scale up to get there? So that was kind of the top line finding from the report. We do see that even though we're far away from this long-term goal, there is a lot of activity happening in the meantime. We're having increasing attention to these engineered novel carbon dioxide removal activities. We're seeing an increase in patenting. We're seeing an increase in research funding. We're seeing a research and demonstration project. So that's all good news and going in the right direction. And I think the final insight that I would add for the report is we still have this need for demand for carbon dioxide removal. So carbon dioxide removal, in a lot of ways, it's kind of like municipal solid waste. We're trying to get litter, rubbish away from people's homes and city streets and put it somewhere else where it's less problematic. And that's what we're trying to do with CO2. We're trying to get it out of the atmosphere and put it underground or in the ocean or in products or somewhere else where it's not contributing to warming. So that's a challenge. And we have to somehow create a demand for this removal. And that's where government and policy will have to play a big role.
Great. Yeah, so I wanted to get into some more of the examples of different types of carbon dioxide removal. So the main method at the moment, of course, is nature-based solutions, such as replanting forests, peatlands, mangrove restoration, and better soil management. But there's also examples around long-term carbon storage using wood products. But the report looked at 15 methods, most of them quite novel. So maybe you could just talk us through a few really sort of interesting examples.
Yeah, sure. That was, by far the most ambitious part of the report. One is to make it global, and 2 is to make it cover the broad swath of carbon dioxide removal methods. And there are many of them. And in the last report we did a couple of years ago, I think we had them in 7 or 8 categories. And now, as you say, we have 15 methods. They range from things that I would call nature-based solutions. And by far the most common is, as you mentioned, is planting forests. And of the 2 gigatons, that's almost all of the 2 gigatons that we're removing at present. So you grow forest, with photosynthesis, you're taking CO2 out of the air and storing it in the woody matter of trees. So that's pretty straightforward. Everybody understands that one. Going into some of the novel methods, another one that's been also fairly established is called biochar. And that's where we take plant material or refuse from forests and pyrolyze it. So that's kind of semi-burn it in the absence of oxygen. And you end up with this kind of charcoal material called biochar. And that's almost pure carbon. And we can use that and put it on agricultural fields and enhance the yield of agricultural production while the carbon stays there, presumably for a fairly long time. And so biochar has gotten a lot of attention recently. Another novel form of carbon dioxide removal is direct air capture. And that's doing a chemical process where we absorb CO2 from the atmosphere and react it with an amine that's like a nitrogen-based solution that's it is what we do on submarines. So people breathe out, exhale in submarines for months at a time without air exchange with the outside environment. And so what has to happen there is absorb all that CO2. So we can do that on a really large scale. And there's plants being built on a really large scale that would be essentially the size of a coal power plant in reverse. So absorbing about that much CO2 and storing it underground. So that's called direct air capture. And then we've got ocean methods, which are ways of using the massive size of the ocean as a store of CO2. And one of these is called ocean alkalinity enhancement. So you can think about solutions being acidic or base, and this is trying to make the ocean less acidic by putting minerals in the ocean. So it's grinding up rocks, put them in the ocean. That reduces the CO2 that's absorbed in seawater, and that allows the ocean to absorb more CO2 from the air. So we're reducing CO2 from the air, which is where the global warming happens. So that's more of an indirect approach, but also something being considered. So we've got several ways to do it, which I think makes me optimistic because not all of these are going to pan out. Some of them might be difficult to scale, some of them difficult to measure. Some might have environmental effects that we just don't like. Some may be less effective at storing the CO2 than we really need. And so having this large portfolio, I think, makes me more optimistic that a handful of them will really work at scale and will give us the removal that we calculate that we need to stay within the temperature limits.
Great. So thanks very much. That was a really good rundown. So now let's talk about cost. Most of the novel approaches remain niche and pretty expensive. Can you give us some idea of some examples of the cost per ton?
Yeah. So we talk about the cost per ton of CO2 removed from the atmosphere. And on one hand, we can calculate costs in a pretty approximate way because most of these novel ways of removing CO2 are only estimates. They're based on academic studies or optimistic modeling about where we could get with the costs. What we did in the state of carbon dioxide removal report is say, well, let's not focus on imagining what the cost might be. Let's look at what the prices that are actually paid, because we do have markets. They're relatively small. Surprisingly robust, though, is these voluntary markets where it's large companies. Microsoft is the biggest example, wants to be a net zero carbon emitter. And as a result, it's buying a lot of renewable electricity, but also realizes it needs to do some removals. And so Microsoft is paying for a lot of removals. And there are many other companies that are paying for removals too, even though for the most part, they don't have to do it. They're doing it because their employees want the company to be net zero. Maybe their customers demand it. Maybe their investors have said that would benefit their stock price. But for a variety of reasons, they're buying removals, and we can look at the prices. And so at the low end, the transactions for protecting forests that would otherwise be harvested or growing new forests, those are on the order of $10 to $15 per ton. So that's pretty inexpensive. And maybe just to put it in perspective, for someone in a developed country where their CO2 emissions are maybe 15 to 20 tons a year, that's talking about $100, $150 per ton per person. So that looks really affordable. Forests are about $12 a ton. Going upward from there into the more novel techniques that are more expensive, we can think of biochar. So that's taking biomass, pyrolyzing it, turning it into this charcoal material, and then spreading it on fields. That's about $130 per ton of CO2 removed. So about 10 times as much as the forest example. So maybe $1,000 per person per year. And then if we look at the higher end with direct air capture, there we're talking about $715 per ton of CO2 removed. And so there, we're another factor 5 or 6 higher than that. So thousands of dollars per person per year. So clearly, if we could do it all with forests, it would be very familiar technology and it would be very affordable. If we had to do it all with direct air capture today, we could do it, but it would be extremely expensive. And so for those higher cost approaches, like direct air capture and to some extent biochar, the key is, can the costs actually go down? And that's really what the industry is working on now. It's not so much saying you should be paying $700 a ton for direct air capture today. It's to say we're paying that now because we think by developing the technology, improving the manufacturing, and getting experience with doing all of that, we can get the cost to come down, like we've seen with renewables like solar and wind and electric vehicles. So that's where we are on cost, with really some optimism that the cost will come down over time.
Yes, well, I saw it from the report that the amount of investment going into climate tech finance is still, as of last year, was still very low. And in fact, carbon dioxide removal attracted only 1.1% of climate tech finance in 2023. So there's plenty of room for that to scale up. And yes, I also take the point, and I think you said this in another interview recently, that there are pretty strong parallels between carbon dioxide removal now and where renewables were 20, 25 years ago. Back then renewables were pretty niche and pretty expensive. Now, of course, the whole picture's changed. Wind and solar are quite cheap, massively deployed, and that will only increase. So I guess, would you say there's hope that there's, a whole range of CDR methods that, will be available at a more affordable price in the future?
Yeah, I mean, that is the hope, but it's optimism that's motivated by experience and history, and as you say, what we've seen with renewables and now with electric vehicles. So we can not only have hope because we've seen it happen before, but we can have hope because we know how those have happened. We know what was done for the cost of renewables to come down and for the deployment of renewables to go up, so that now we're talking about a sixth of the electricity system is from wind and solar, and that's growing very quickly. So we can learn things from that. Some of the things that we've learned is that strong, active policy can find ways to get the cost down. And that could be at the early stage, like funding research and development into things like materials or modeling the flows of carbon in the ocean and how it interacts with the atmosphere. So additional funding and support for that kind of work can really help. In later stage, what can be really helpful, if we use renewables as an analogy, is some of the early demonstration projects where the projects were still very expensive. The electricity produced was not competitive with that from fossil fuels. But governments, I think of Denmark as a good example here, subsidized some of those early deployments to prove the technology, to show people that it actually worked, and to inform the industry about what could be done to bring the cost down. And we are seeing that in carbon dioxide removal, where in the US, there was a $3.5 billion program for demonstration projects. They're called the direct air capture hubs. And 2 of those have been funded and are beginning to be built. And so that's additionally learning from what's happened in the past that makes me optimistic that the industry can scale up and costs can come down. And ultimately, what we really need is to create strong demand for carbon dioxide removal. So right now, the biggest demand is voluntary. It's companies like Microsoft and others that, for a variety of reasons that previously mentioned, they're willing to pay substantial amounts for removed CO2 to achieve their net zero targets. Eventually, we're going to have to move on from the voluntary to policy, which in a variety of ways could create markets or just create demand for carbon dioxide removal. And so that'll be really important. The final part that I would highlight is if we look at the renewables industry, it really was based on a global innovation system where we had efforts happening in one place, like I mentioned, Denmark for wind power. We can think of solar, what happened in Australia and China and Japan and Germany. And each of those contributors to the scale up of solar, in that case, had something distinct and built on the capabilities of the others. And as we look at the world environment today, there's a lot more tension and there's restrictions on trade and tariffs that have gone up. And so finding ways to overcome those, and that's where we think an international organization to support carbon dioxide removal might be really important here, to share lessons about what's learned, to collect and distribute information about the industry, what's growing, to answer a bunch of the questions that you've asked on this podcast, and making those data public and shared internationally. I think that's a way that we can scale up the industry and allow the cost to come down as well.
Great. Yes. I mean, you actually very nicely answered the question I was about to ask you, which was what policies are needed to really stimulate innovation. But thank you. That's already answered that. So, but I want to move on to some of the concerns about some of these more novel methods as to whether they're truly sustainable. And I think there are concerns about ocean fertilization. And some of them, they look to be some environmental risks, also including, say, biomass sinking into the ocean or bio-oil storage. So maybe talk us through some of the concerns about some of these methods and how to make them sort of more sustainable.
Yeah. Well, the environmental risks are very important. One, because, we're trying to address an environmental problem with climate change. And so if we're improving one problem by sacrificing on another, that's not really, I think, where most people want to go. So they're really important for that reason. And second, environmental issues are important because to make any of these, say, 15 approaches to carbon dioxide removal relevant to the climate, that is big enough that they actually produce a signal and offer some cooling, then we need them to be big. And we know from the past that when you scale up human activities, there's inevitably impacts. And so to foresee some of those impacts and work them out and mediate against the worst ones is crucial. And I really think the next 10 years is a time for some small but increasing scale of experimentation to see what happens with carbon. If you put bio-oil underground, and does it move around? If we put carbon in soils, how long does it stay in the soils? If we try to fertilize the ocean, for example, iron is something that can lead to algae blooms, which in most nearshore and small water bodies we want to avoid. But in the ocean, that's taking carbon. And so that might be a way to store carbon. But where does that carbon go? Does it get eaten by fish and then end up just being put back into the atmosphere? Or does it sink to the bottom and really store CO2? And those are open questions that we have. So it's really a time not only of experimentation, but of understanding the sustainability impacts really for the next 10 years. And that may lead us to rule out some of our 15 approaches and say, this is just not worth it because the environmental issues are too severe. Or it might lead us to say, this is a great technology, it's affordable, but we have to somehow address this issue. And that leads to further innovation. And we have precedents for that type of thing happening as well. So yeah, we really need to take those environmental impacts seriously.
Great. Thank you very much for that. Yes. I mean, I guess, so what's your final sort of top line elevator pitch message about CDR? Is it that it's regardless of how much CO2 removal we do, the other critical thing, or perhaps the most critical thing, is we actually have to reduce emissions in the first place from fossil fuels and deforestation? Or are there other sort of key messages as well?
That's key message number one. I think it's so important, if we talk about carbon dioxide removal, that it addresses something like 15% of the climate problem. So if we have to get emissions from where they are today, about 55 billion tons a year, down to zero by around 2050, that we can do about 15% of that with carbon dioxide removal. And the rest, 85%, has to be cleaning up our transportation system, our energy system, our industry, and our agriculture. And we have lots of tools to do that. So whether we do a lot or little of carbon dioxide removal does not change that we need to rapidly reduce emissions to really low levels, starting as soon as we can. So that's message number one. I think message number two is really about this shift toward needing to understand where we're going to have demand for carbon dioxide removal. And this is really a pointer to policymakers to say that the voluntary markets, companies, have been keeping the industry going and really improving it and developing it for the last 2 or 3 years. And that's been really helpful. And now it's really getting to be time for governments to step in and say, we're going to support the research, we're going to fund further demonstrations, and we're going to create expectations that there'll be a long-term demand for removed carbon dioxide removal that will last far into the future. That's what we got with renewables. That's what we got with solar in 2004. Really, the German government saying we're going to offer 20-year contracts for buying solar electricity at double the retail price. And that led to strong investment, really low investment costs, like 2% financing rates, because there was no uncertainty that there'd be a market for solar. That's what we need for carbon dioxide removal. We need to create this confidence that over the next 5, 10, 20 years, the length of time it takes to scale up a technology and make it go big, that there'll be a market for that, remove CO2. So that's really where we go next, as to how to get that policy regime and policy environment to be supportive, so that those involved in carbon dioxide removal see a future of a growing industry and a growing amount of removals to be paid for in the future.
Great. Thank you so much for joining us today, Greg.
Thank you. Happy to talk.
Well, that wraps it up for Green Pulse. Once again, I'm David Fogarty, and thanks for listening.
Send your feedback to podcast@sph.com.sg. Find us on Apple Podcasts, Spotify, or within our Straits Times app. Thanks for listening.